Hello, everyone. Good morning to everyone. We'll start in a couple of minutes. Hello, friends. Once again, welcome to everyone, and very good morning to all of you. We'll start in a minute. Hello, friends. Once again, welcome. I hope all of you got the link from the community. So I see still the students are joining. Okay, so before we start, as you know, if you have any questions, meanwhile you are taking the session, okay, so you have to log into the community, right? So as you know, already all of you are on community. So once again, let me give the instructions. So once you visit our website, you have the link for the community here. Once you click on that, if you are already a member, it will actually log in into the community, right? So once you log in, here you'll see ask the expert. Okay, so during the session, if you have any questions, please please post your questions in the ask the expert session. Okay, yeah, so I hope that is clear. So I see still our friends are joining. Okay, so welcome everyone to this new NASO Power Up. Every time we are bringing new topics, right? Since last few weeks, you are getting a lot of information on the NASO Power Up, right? So whether it is preparation for the exam, NASO exam, I hope you some of you had good time with the exam. Okay, so I got some message from our students that they did very well with the NASO exam. Okay, so that's great. I hope you are all doing great with the NASO exam. And again, once again, welcome back to the new NASO Power Up. So as you know, since last few weeks, we are having this very exciting topic back to back, and that is on the space rocks. Okay, so you have seen Vikram sir talking about the how to defend our Earth from the asteroid, right? Asteroids hitting the Earth. Okay, so then we have seen how we can report the asteroid, right? How we can actually search for new asteroids and report to the scientific community. Okay, and this time it is going to be one more exciting thing. So this time we are actually going to learn about what are meteors, okay, and how we can observe and report, okay, for the scientist and how it actually helps. Okay, before that, I have uh, a test for you, by the way, okay, because you already learned about all these space rocks. Okay, I have a test for you before we begin. So here I give 20 seconds to you. Okay, so you see different kinds of objects here, right? So you have to actually think of naming these objects. Okay, think yourself, and you'll have 20 seconds to answer. So time is already 10 seconds up. Think about what is what object in this. Okay, time is up. Anyhow, I will start the timer again. Okay, so that whoever missed it again, they can attempt. Yeah, So we have 25 more seconds. Think of it. What are these objects? I know most of you know the answer for this. Okay. Ta-da! Time is up. Okay, so here you can see the left one is dwarf planet. We have a comet, asteroid, meteors, meteor shower, meteorite. Okay, there are different kinds of names. I know some of you know very well about these objects, but we are actually going to learn about them. So are you ready? Okay, let's see how many we have. Yeah, so still people are joining. Okay. So we are going to talk about meteors today. Okay. So not every object, you know, almost of them. So what are these meteors? If you look at visually, they are just like, you know, streak of light, which is flashing in a fraction of a second in the sky. Okay. Yeah, but today we know what are they, right? So if you don't know, we are going to learn what are these, by the way. But in the ancient times, in the in the olden days, actually historically, they were not understood very well, right? So people used to think that they are actually shooting star-like objects, right? Okay, so they used to think that they are like shooting stars. So do you think, are we really looking at the stars which are shooting in the sky? Do you think the stars will just move like that in the sky? Obviously no, right? Okay, they are not stars which are shooting. Obviously they are not the stars. Okay, so then what are they? What are they? They are very small objects. Okay, so they are very small objects which actually burn into our atmosphere, right? Very small objects. So they range from few millimeters to 1 meter approximately. Okay, if something is beyond 1 meter, it is actually called an asteroid. Okay, so here it has to be within few millimeters to 1 meter. So these are the objects, okay, which are actually burning into our atmosphere. That's fine, sir. But what do you think? Where are they actually coming from? Where are they originating from? Is somebody throwing in space? Okay, yeah, obviously no. As you know, in our solar system, when the solar system is formed, obviously it formed our sun, okay, planets and moons orbiting it. But apart from that, there are a lot of materials, okay, which are left over. These are the leftover materials from the formation of the solar system, okay, which didn't turn into planets or moons, okay. So these leftover objects are many, many, many. So do you think how many these space rocks, or they are also called small bodies of solar system? So do you think how many do you think they are there in the in our solar system? Can you guess the count? Few thousands, few lakhs, few millions? No, it is actually 1 trillion. Up to 1 trillion small bodies are there in our solar system. Okay, they are called space rocks, by the way. Okay, so then, okay, sir, that's fine, but where these meteors are coming from? They're actually coming from these space rocks, okay, which are especially, you know that they are located between Mars and Jupiter as a main asteroid belt, and they're also located in the Kuiper belt, okay, which is beyond Neptune, right? And also there are some objects which is in the Oort cloud, which is the farthest, thing in the solar system, right? So now there are few things, okay, there are these space rocks actually coming from these. So they're actually having their own orbit. So how actually they come inside the solar system? Yes, they can come. So let's talk about this Kuiper belt, okay, and Oort cloud objects. So as they're very far away from the sun, they're pretty cool, isn't it? So they're actually covered with ice. They are called actually the dirty snowballs. Okay, so these dirty snowballs, what happens, sometimes they collide with each other, and sometimes they get deviated because of the solar radiation as well as the gravitation effects of these huge planets, the gas giants. Okay, so once they deviate, they actually come inside the solar system. That means they are already in the solar system, by the way, but they're outside. So they'll come towards the inner planets and near to the sun. When they're coming, obviously they are made up of ice and dust, right? So they will start evaporating these materials, right? Okay, so there is something called sublimation process. So the solid material directly converts into gaseous form. So you might have learned in your classes, right? That is called sublimation. So these objects, these icy objects, okay, which are there in the Kuiper belt and Oort cloud region, when they come near to the solar system, near into the sun, okay, So what happens? They start developing a very interesting feature, that is the tail. Okay, and these are known as comets, obviously, as you know that. So as these are evaporating the materials, okay, sublimating the materials, and the dust, actually they are very, very fine dust, by the way. So this is called a space dust. The space dust is actually left by these comets as they come near to the sun and they leave, right? So but the dust is still there, isn't it? And sometimes what happens, our earth actually passes through this dust. When the earth is passing through this very tiny particles, less than 1 millimeter size, okay, then very interesting stuff happens, and it actually showers. Okay, so we see a lot of meteors. Okay, in recent times we had something called Geminids meteor shower. Okay, yeah, so every meteor shower has its origin. Okay, its origin. So recently we have seen Geminids meteor shower. Okay, so which is coming from one comet, right? The dust left by one of the comets that we have in our solar system, right? Okay, so it's very, very interesting to see. So if you have access to dark skies, definitely you can see that. But everybody doesn't have access to dark sky, right? But I have a plan for you. Okay, so don't worry about that. Yeah, actually you can see even in cities some of the objects. We'll talk about that. So obviously these comets, the dust which is left by the comets will actually result into meteor showers. So there are some major meteor showers that can be seen in a year. Okay, considering the local weather conditions. Okay, so now from where else we'll get meteors? So there are also some small bodies, right? Space rocks apart from these comets. Okay, they are metal bodies, right? The small rocks. Okay, the space rocks which are made up of mostly rock and metals, and they are mostly lying between Mars and Jupiter, right? So sometimes what happens, they are orbiting in their own, or in their own path, but sometimes they actually collide with each other, isn't it? So when they collide, again they break into pieces. Okay, so when they break into pieces, they actually break into kind of big pieces rather than comets. Comets actually sublimate the material into very fine space dust, right? Whereas when asteroids basically, or the space rocks which are there in the asteroid belt, when they collide, they break into kind of a little bit bigger pieces. And these bigger pieces are actually called meteoroids. Okay, meteoroids, right? There are different terminology, as you know. Okay, so these asteroids actually break into meteoroid. Even comets sometimes, okay, if the comet is big enough and it is having so much of solar radiation and speed, what happens, they also break into bigger pieces. So sometimes comets and most of the times asteroid break into bigger pieces, and they are called meteoroids. Okay, so when they break into bigger pieces, like that is meteoroids, and these meteoroids again range from a few millimeters to up to 1 meter. Okay, so these meteoroids actually, they just roam freely. Okay, they roam randomly in the solar system. They don't have any specific orbit. Okay, but sometimes some of them, what happens, they actually strike the earth. They cannot directly strike the earth, right? We have some layer, okay, above the earth, that is nothing but our atmosphere, which is protecting us from many, many things, right? Okay, so now it has to strike the atmosphere. When it is striking the atmosphere, actually it actually fires up. How come it fires up? Do we have something to burn in the atmosphere? Yeah, obviously we have oxygen, right, to burn. So but even if you don't, if not oxygen, with the friction force. So with the friction force, if you're rubbing your, right now you can do with me, okay, so you can rub your hands very fast, and that is it. Right now we are in winter, right? If you are feeling cold, what do? You rub your hands, right, to heat up. Okay, so imagine these meteoroids which are actually entering into the atmosphere with high speed, right, few kilometers per second. Then what happens? A lot of friction takes place between the atmospheric gases and these meteoroids, and then they fire up. Okay, and some of them will survive based on the sizes. Okay, the smaller ones which are in few millimeter size and centimeter size, they don't survive. If they're few centimeters to up to 1 meter, they actually survive. And survival also depends on what kind of material they are made up of. Okay, we'll talk about that. So when this meteor actually survives, so what happens when it is in the space as a space rock, very small body, that is called meteoroid. When it actually enters into the atmosphere and fires up, it will become meteor. And when it actually strikes the surface of the earth and lands on the earth surface, it is called meteorite. Okay, got it? So asteroid or comet breaks into meteoroid. Meteoroid enters into the atmosphere of the earth, becomes meteor. And when meteor survives and lands on the earth, it becomes meteorite. I hope that is clear. And already you have learned about this right before. Okay, superb. So when you look at this meteors, actually which one, the one which actually survive, they are actually very much rich with the metals. Okay, here you can see it is very rich with iron, and here we have some of the very interesting meteorites. Okay, so which are actually a combination of a metal and some crystals, right? It looks very interesting. Okay, it looks like a gold, but it's not a gold, by the way. It's a crystal which is embedded in metal. Okay, so because in space a lot of collisions happen, so different kinds of material can kind of hit each other, they merge into each other, and forming into this kind of very interesting features. Okay, and also we have different kind of meteorites, right, which are mostly made up of metal. Okay, we have chondrules, we have silicates, and all those things. Okay, metal grains or everything is there, right? So that's fine. We are getting these meteorites. What do we do with them? Okay, what do we with them? So what do you think? What we can do with them? Yeah. So think about what about our ancestors? What they used to do with this when they find these kind of meteorites. So actually, they used to make knives. They used to make tools and statues actually. So here we have some examples. Here on the left you see that. So here is a meteorite which actually fallen almost 1500 years ago in Greenland. And here the Inuit culture there, Inuit civilization there actually collected this meteorite, which is rich with metal. Okay, iron. So they actually made into tools. They actually build the tools and weapons out of that, because it is very rare to find these kind of things in that area, right? Okay, they were using them to make a tool. And we have also seen in the one of the greatest civilizations on the earth, that is Egypt. Egypt mummies, right? Yeah, they're very famous, obviously. The pyramids, and also they actually found weapons. Okay, the knives actually, which are the swords, small swords actually, which are made up of material from the meteorite. That kind of, it tells a story, right? How meteorites were actually collected since many years. Okay, so this might be, the scientists say that this might be actually gifted by someone. Okay, so yeah, it is having very rich metal content along with nickel. Okay, nickel and iron, which is very rare to find on the earth. It will be only or found via the meteorites. Okay, so meteorites have very interesting combination of metals which is normally not found on the earth. Okay, so that is how they were able to confirm that it is actually made from the meteorite, obviously, right, which is carried from space. So again, some archaeological department from China actually found this statue, which is also made up of the meteorite. Okay, which is again rich with iron and nickel. Okay, so now in modern days, what you do with them? Okay, back then they used to make these tools and statues and all. In modern days, what we do? We find most of them in the museum, right? Okay, so some of you might have gone to the museum and seen this. Okay, so you can actually find in India also. You can go to some planetariums, basically. You can actually find them. So here is a museum display of a meteorite, okay, which is one of the biggest to collect so far, which is there, which is actually a piece of 150-foot meteorite, which actually strike many years ago. Okay, so what do you think, sir? Are they just tools? Are they just materials to make tools, statues and everything? Do they have scientific value? What do you think? Do they have scientific value? Think about it. Yes, obviously they have scientific value. Okay, so why? Because they're coming from space. They're carrying some information about the formation of the solar system. Yeah, so because they are actually leftover bodies, leftover pieces of solar system, right? Obviously, and they are preserving some of the original composition of the solar system. So when we find them, we can actually find what material actually led to the formation of solar system. What were the composition of the solar system in the beginning? Okay, so what material actually bought into the solar system, which actually led to the formation of planets and moons? Okay, it's very important. Right here you can see the museum display in Bangalore. Okay, in planetarium, right? You can, if you are interested, you can actually go to these planetariums in India. You can find these meteorites. Okay, excited? Yeah, super. So now, are they just museum pieces? No, obviously. Okay, we have to the scientists, actually the meteorological department, as well as the astronomers, actually take them to study. In recent times, we have seen in 2020 and Bihar, one meteorite fallen, right? It is named actually as Mahadeva. Okay, so here you can see it is actually carried to the physical research laboratory in Ahmedabad, and they are actually studying on that. Okay, so what it is made up of, how old it is, and all this stuff. So with this, we can actually find out the age of the solar system very accurately by looking at the lot of materials are, a lot of scientific analysis can be done on this, right? Here you can see Bihar CM is actually looking at it. Okay, yeah. So if you are interested, obviously, you can also go and see that. Yeah, if they allow. By the way, yeah. So now that's fine, sir. Actually, then what we can do? What we can do to help scientists? Do we have to find a meteorite and work in the lab? Do we have to go out and search for these meteorites? Do you think it is easy? Obviously, no. Okay, it's not that easy. It's very, very rare, right? Once in few years, they will find it. If somebody is reporting them. Otherwise, a lot of meteorites actually go unnoticed because they are also falling in the daytime, right? We cannot see. So there are a lot of them are unnoticed. But you don't have to go out and search for a meteorite and work in the lab to help scientists to understand about these objects. What we can do, sir? Do we have to go into space? No, you don't have to go into space. Okay, so we have to just observe the meteors and report them. Okay, you don't have to look at a meteorite, by the way, which is falling on the earth. You just look at the meteor, which is just burning into the atmosphere and never coming to the earth. Okay, so you can actually observe that. So how to observe these meteors then? Yes, obviously we have a plan, and there are ways to observe. But do you need any telescopes like this? Do we need telescopes and binoculars? No, you don't need telescopes and binoculars, by the way. Okay, you don't need any special tools because already you have a special tool with you since you are born. Okay, we are gifted with our eyes. Okay, so you have to use our eyes. Obviously, you don't need any telescope because when you're looking through telescope, right, it will look at very, very small region in the space. Correct? It has very small field of view. It looks at only one small patch of the sky. But whereas meteors come in any direction, right? It can come from here, anywhere. Okay. So that is the reason in our eyes, which are having a good field of view, okay, we can see up to 120 degrees, right? So obviously our eyes are best tools to observe these meteors. Okay. So they are also often called shooting stars. Okay, meteors. So you have to observe meteors, sir. I live in cities. Okay, so most of us live in cities, right? Okay, so sir, we don't see them often. Yes, because there's a lot of light pollution in the cities, which restricts us actually to looking at these meteors, right? And they don't come every day, by the way, right? So, but there are some meteors which are actually very bright. Okay, because most of the meteors will be very, very faint. Okay, very faint, and they'll just go like this in a fraction of a second. We cannot observe them from the city. It's very hard to observe. But some of the meteors which actually have sizes up to few centimeters to 1 meter, they actually burn very, very bright. Okay, yes, they burn very, very bright, and these very bright meteors are actually called fireballs because actually they look like a fireball, right? So they actually look like a fireball, like a dragon fireball. You might have looked into these mythological stories and all, right? The dragon fireballs and all. Yeah, so it actually looks like that. So we cannot see the faint meteors, by the way. You have to travel to some remote locations with very less light pollution to see these very faint meteors. But to see these fireballs, you don't have to travel to very remote locations. You just should have a clear sky from within the city. You can observe. You can go to your terrace. You can go outside and just observe and lie down. If you have some chair, okay, it will give you a relax. If you have a bean bag and all, you can go to the terrace and actually observe. You can actually do tonight. Okay, so this is the best period to observe meteors. Okay, from India basically. So I will tell you how to observe and all. Okay, so you can just go to the terrace, just lie down. Okay, relax, just look at the sky and wonder about these fireballs. Okay, yeah. So that is how you can observe. That's fine, sir. When I observe, what I have to do? What I have to do after observing? Obviously you have to do something, right? So what to observe? First of all, you have to observe the colors of them, the colors of the meteors or the fireballs. So why colors, sir? Is there any special thing about the colors? Yes, obviously, because if you want to test any material, let's say you have collected the meteorite, right? So they'll take in the lab and they will burn it, check the composition and all. They will do the spectroscopic analysis and all those things, right? Okay. But here, who is burning to do the test? We have to do the flame test for them and all those things, right? So here you can see in the lab what happens. They will take the sample and do the flame test. Okay, they will get the color, and based on the color, we can actually find the composition of it. Okay, you know that if you're burning a wood, it burns in a different color. If you're burning methane gas on your gas stove, it burns in a different color, right? Your matchstick burns in a different color. So yeah, obviously the material, what it is made up of, it actually the composition of the material actually leads to different color. So here, who is burning, sir? Who is doing the flame test? Actually, our sky is the lab for us, right? Our sky is the lab, because when the meteor is actually going through the atmosphere, because of the friction, it is burning with very, very high temperature, right? Okay, it is firing up, obviously. So that is how we can see the color, right? We can see the color, and these colors indicate a lot of things. Okay, so do you have to do the analysis? Do you have to know which color is what and all those things? Do you have to do the analysis of all those things? No, you don't have to do, but you should have some knowledge about that also. Okay, yeah, you can see that samples of these meteors are actually burning into the space, right? The sky is working like a lab. It is doing the flame test. You just have to observe with your eyes. Okay, so here you can see different meteors. These are the actual images of the meteors as well as the fireballs. You can see it is an yellowish color. At the tail, it is kind of a greenish color. And here you can see it's kind of a rainbow color. You can see white, pinkish, greenish, yellowish, and everything, right? And also here you can see green at the tail, white and blue color also, right? So yes, so they actually appear in different colors. I have seen more than almost eight fireballs, okay, in last 6-7 years. Okay, so we'll talk about how to report them also, right? So here you can see different kinds of colors. Okay, so here the color actually is because of many reasons, not only just the material, that the composition of these fireballs or the meteors, but also depends on at what speed they're traveling within the in the space and the atmosphere, and also depends what kind of atmospheric gases it is passing through. Okay, because the combination of all these things actually affect the color, the speed, okay, the composition of the meteor, and also the gases that are present in our atmosphere. Okay, yeah. So if these materials are actually going into like Martian atmosphere or the Venus atmosphere, right? So they might be burning with a different color, little bit difference. Okay, that will be there, by the way. Okay, so now after looking at the colors, what we have to do, sir? So again, when you talk about colors, here you can see, so the yellowish is mostly because of the iron content present in these fireballs or meteors. Okay, so if it has a rich content of sodium, it actually burns a little bit orangish. Okay, if it has nitrogen and oxygen, it actually burns reddish. Okay, and if it has calcium, it burns in purple color. If it has magnesium, it burns in blue color. Okay, this is a generic color distribution, but it is not 100% true when it comes to the fireballs and all. Okay, it also depends on the speed and the atmospheric gases, as you know. Now that's fine, sir, but where to report? Okay, there are some citizen science projects. Okay, so as a student also, you can actually help scientists to trace out these meteors or fireball, because so we already know there are some comets in our solar system, right, which are coming near to the sun. And if you know, the thing is, the comets are actually very hard to capture, right? Obviously nowadays there are some missions which are being sent to understand the comets, but what is happening, these comets are actually leaving some dust material, right? Space dust. Okay, our earth is passing through that, and the sample which is left by the comet is actually burning into the atmosphere, right? We can observe that. And similarly, asteroid pieces, which are meteoroids, which are also coming into the atmosphere and then burning like a fireball. Okay, so we are not able to go to the asteroid, right? It will be very, very costly. We need a lot of rockets and all, a lot of money to go there and take the sample. But here they are freely leaving the samples, right? And these samples are actually being burnt in the atmosphere, like a fire test is also done in the atmosphere. You just have to observe. Okay, because a lot of science can be done freely. We don't have to send rockets and all. Okay, so here you can actually help them, because scientists cannot go out there, out in every country, and cannot lie down and look at the sky, right? They need a lot of people, okay, to help them. So like you, who are very much curious to explore the space and to understand these things, right? So there are two projects, which is IMO, International Meteor Organization, is there, okay, as well as American Meteor Society. So these two organizations actually are helping to helping the citizen scientists and student scientists, basically, to help them to categorize these meteors and report these meteors as well as fireballs. Okay, so most of us are going to be seeing fireballs basically rather than meteors. Okay, so now let me open this. Okay, so let me open this website. Okay, so you can just search in the Google that American Meteor Society or IMO, okay, International Meteor Organization. So you will be going to this website. So here in this website, you see that there are a lot of tabs here, right? You can see that. So meteors, you can go to the meteors, okay, fireballs, because most of us are going to see the fireballs, right? So here, what you have to do, report a fireball. You have to click on that, okay. Yeah, then it will be coming to this page. So even if you go to the IMO website, okay, so let us go to the IMO website. So here, if you go to the home page, you have a lot of links there, a lot of information there. So right now you can see Gemini's meteor shower is going on, which is very good for us, okay, so that we can observe them. And also if you go to the this website, AMS, also there it indicates the current activity which is going on, okay, like Geminids, Ursids and all, okay. So yes, so here also you'll see what is the origin of them, okay. So all of those information will be given, okay. So what object, what comet, what asteroid is actually leading to these meteor showers or meteors, okay, fireballs. So you'll see all this information. So if you want to report a fireball, go to the report a fireball, and even in IMO website, so there is a link there to go to the report a fireball, okay. So you can scroll down to find a lot of news about these meteors and fireballs, okay. So then you go to the report a fireball page, okay. So here you can see report a fireball. Once you click on that, so both the websites actually are using the same same servers and all here, okay. So you can actually visit IMO, either IMO, or you can visit the AMS website, okay. So here, if you go here, if you go to this page, report a fireball, let me close other tabs. So here there is a link, okay. And one more thing is that, see, everything that actually burns like a meteor is not a fireball or meteor, okay. So you have to know which is meteor and which is not a meteor, okay. So basically there are some false signatures. What are these false signatures? So here, when the rockets are launched, if you're living near to the rocket launch centers, for example, in India, we have Sriharikota, right, which is the launching center. If some of you living in Chennai or nearby the Sriharikota region in Nellore district and all, you will see rocket launches, right? So these rocket launches actually also look like a fireball. Okay, yeah. And also, you can see the different stages of the rockets. You can see they will appear in different colors based on the fuel that is used in the rockets. Okay. And not only that, you'll see sky lanterns sometimes moving in the sky, right? Sky lanterns are also there. And also satellites. We can actually see artificial satellites in the sky after the sunset or before the sunrise, in the VRs basically. So here we can also see satellites which are moving like a stars, by the way. They are also looking like, moving stars. But they are not meteors. Why? Because these events last for a few minutes. Okay, when the rocket is launched, it will take some time, right? You will see it for a few minutes. Okay, if you're seeing a lantern, that lantern also is visible for a few minutes. Okay, if you're looking at a satellite pass, okay, that also lasts for a few minutes. So generally, if you talk about meteors and fireballs, they don't last more than few seconds, approximately 5 to 10 seconds. Okay. So yes, not more than that. So that is how you actually know which is meteor or which is not a meteor or a fireball. Okay, so that's very important. So let us go back to this page. Yes, so now you understand which is meteor, which is fireball, which is not a fireball, right? Okay, now once you've done that, then you have a button to start. Okay, you click on the start now. Then they will ask, do you have a photograph or a video of this event? It's very tricky to photograph. Why? Because you have to take long exposures and all those things. So you should know a little bit of astrophotography if you want to photograph these meteors, okay, and fireballs. But if you're lucky enough to capture them, that's good, super. You can actually upload the video. If you have a photo, you can actually upload the photo. Okay. So let's say if you have a video of this event, you can click on the yes. If you have a photo also, you can click on the, if you don't have, you can click on the no. Okay. So if you are clicking no, that is also fine because your eye is evidence, right? if you don't have photograph or video as an evidence, your eyes are an evidence. Obviously, you have to report. You are reporting truly, right? Okay. So then after that, you have to give the address. Okay, from which location you have observed this. Okay, so you can give the address, whatever address, yeah, whatever location you have seen from. Approximately, you can give, this particular street, this particular city, or this particular village in this particular state. You can give that. Okay. So once you give that, you continue. Okay. So for example, I am giving our office address, let's say. Okay, so then continue. Yeah, so here once you give the address, it will actually take you, okay, the icon, the human icon, to that particular location, whatever you have entered. Okay, so from that location, actually you have to indicate, okay, where actually you have seen from. Okay, so approximately it will take to your location, right, whatever location you are given, and you have to pinpoint, you have to move this human icon to the exact location where you actually observed from. Okay, so let's say I have observed from this particular building, the terrace of this building, I move that particular human icon there, and then I continue. Then I have to give the time and date, obviously. So let's say I have reported June, okay, this particular date, this particular year, 2022, okay. Then you have to give the hour, which hour you are actually, you can convert into AM, PM, 12 hours format also. So you can say like 4 AM, let's say, then you can give that. How long did it last? You have to give that information. So approximately based on your observation, okay, it's very important to note down all this information after your observation. Once you observed it, okay, so first think of it, okay, recollect the event, because it is likely that after you are recollecting after a day or few hours, you will forget few things. Okay, so once you observe this event, the fireball event, okay, or meteor event, you have to recollect it, from which direction it has passed and how much time it was there in the sky. Okay, so basically meteor is going to be very fraction of a second. Okay, meteors are not going to appearing more than half a second or 1 second, but fireballs will be appearing for more than 2-3 seconds, up to 10 seconds also, you can say 10-15 seconds. Okay, so here you can say, let's say if you have seen a fireball, let's say you can we have seen 2 to 5 seconds, you have to give that and continue. Then you have to give, you have to confirm whatever information you have given, it is very true. Okay, yes, that is right. You have to click, that is right. If you see, if you think it is, again, you can modify that timing and all. You can actually go back, no, this is wrong, and click on that and actually go back and modify that. If it is right, obviously, yes, this is right, you have to click on that. After that, you are going to be asked, to give the degrees, okay, angle, at what angle the fireball actually was, seen. So if you have seen, okay, you might be seeing any direction, it doesn't matter. Next, it will ask for the direction, by the way. So, but first of all, you should recollect, okay, at what angle it has gone. If you're looking like this, let's say towards this direction, if it has gone like this or like this or like this, vertically down, all those information we have to recollect and give this. Let's say the meteor has, the fireball has gone this way. Okay, let's say this way. Okay, for example, so you have to turn this actually bar here, and actually you can indicate that angle. So then continue. Okay, so far so good, right? Continue. Yeah, so then you have to click okay. So then direction you are facing. So then next we will ask about the direction, in which direction you are actually facing. You should know the direction information also. Okay, so after, as I said, after your observation, you should actually recollect everything and write down on a paper, or note down on your mobile phone or whatever it is, or record yourself about that particular event. Okay, so here now you have to actually indicate, in which direction this fireball was appearing. Okay, so let's say you have to click here. If you click a mouse, here and here, based on that, the arrow mark will be marked. Okay, so you have to click. So if I say, if I recollect that, if it is in this direction where I was seeing, then you have to give that direction, okay, approximate direction, and then continue. Now after that, the fireball is not going to be in particular direction, right? It will actually start from one direction, it will end in other direction. So previously what you have given the direction where you have actually seen, okay, approximately. Okay, so right now you have to give from where it has started, from where it to, at what direction it has ended. And most of the times what happens, actually, you may not be seeing the entire event. Okay, let's say there is your family or your friends, they will see it. Oh, see the fireball, then you will see it. Okay, you might be missing the some parts in the some 1 or 2 seconds in the beginning. Okay, that's fine. So since whatever time you have seen, at whatever direction you have seen, you have to report that. You may not be seeing the entire event, by the way. You will be sometimes missing it. Okay, you will be seeing in this direction, and the fireball will happen in a back in this direction also. We don't know, right? So but whatever we have seen, whatever you have seen, you have to give that accurately. So then you have to give next the in which direction you have seen the fireball first. Okay, so I have seen this here in this direction approximately, right? But I would say it has actually started from here, a little bit left of me. Then I click continue. Then in the next step, you have to give how much high it was, when you are observing it. Okay, how much high in angle, okay, from the ground. So how far above the horizon was it, in the first appearance? You have to give that information. So here is the green line which indicates the horizon. Okay, so let me zoom in a little bit. So here is a green line that you see which indicates the horizon. Okay, your visibility of the ground. So you can actually move this bar up and up, actually upwards, and indicate at what angle, at how much height. This is called altitude. Okay, in sky coordinate system, it is called altitude. Okay, so how high it is actually appeared. So if you have some, actually in one of our courses, we teach about the altimeter, how to make an altimeter out of your protector and a straw and some thread. Okay, it's very simple to make. If you can also make this that kind of a device and actually approximately indicate how much high it is. Okay, with that particular device. If not, there are some apps which actually help. For example, Stellarium. Stellarium is very good software using which actually you can recollect. Okay, so as soon as you observe what you do, as soon as you observe, what you can do is you can actually, just a second, you can actually open Stellarium, whether in your system or on your mobile, because mobile access will be easy, right? So as soon as you see the fireball, you have to open the Stellarium and approximately see how above it is. How you can use Stellarium, sir, to use to know the angle. Yeah, so the thing is, when you're seeing this fireball, you might have you might be seeing the moon. Okay, if there is a moon in the sky, you can actually use moon as a reference, okay, to find the directions as well as the angle. Or if you see some stars, if you're able to see some stars, also you can use the stars which are available. Let's say tonight I am able to observe, let's say I am going to the night. Okay, just a second. Yeah, let me fast forward to the night. Yes. Okay, so you may not be seeing this many stars, by the way. You might be seeing some planets, like for example, Saturn, Moon, or Jupiter, Venus. All these planets are visible clearly. Okay, from cities also. You can use them as a reference. So, for example, you have seen a fireball, let's say in this direction, like this. Okay, and if you have seen fireball going in this direction, you can actually use moon to indicate the angle. Okay, how much high it was when you observe. How you can use, in this Stellarium, we have coordinates here to indicate. Okay, you can go for this coordinate, which is the coordinate of altitude and azimuth system. Okay, like a compass directions. You can use that. And here there are some grid lines. Okay, these grid lines actually help you to identify how much high the moon was when you are observing. For example, if you zoom in, here there is an angle, right, around 50 degrees. Okay, if you zoom in, you'll see that angle. Okay, so the moon was actually at 50 degrees. If you see this fireball at this particular angle, then you say that, okay, sir, you can report in that website that it is actually passing around 40 degrees. Okay, so based on the information that is available already. Okay, the location of the Saturn or any other planet or the moon. Okay, so you can use that. If you see some stars, obviously you can use those stars as an indication of an angle. Okay, using this software. That way you can accurately give the information. Okay, so I hope that is clear to you. And after that, what we can do? So after that, here you come to this page. Obviously, you have to give the information here. Okay, let's say it is 40 degrees somewhere. Here I can give manually also. I can give like 40 degrees. Okay, and then continue. Then I have to give at what direction we have seen the fireball, finally. Okay, so it might have started in one particular direction, and it might have gone to some height, and it will be ending in particular direction, right? If it is ending in certain direction, okay, then we have to give the direction. So as I started from here, okay, so it might have ended here, let's say. So if I see it is ending in this direction, then I have to give that direction and continue. So after that, again, we have to give the information when it is ended. Okay, when the fireball event actually ended, at what angle it is ended. Okay, from how much high from the horizon it has ended. So let's say it is ended at 15 degrees. Then I have to scroll this bar and indicate 15 degrees. Okay, so then continue. So here we have to give the information of the brightness of this particular fireball. Okay, how bright it is. So there is a brightness indicator, there is a brightness scale that is there in the astronomy, okay, scientifically, and that is called the magnitude. The magnitude information means the brightness information. Okay, so our sun, for example, without cloud skies, okay, if the sun is clearly visible to you in the daytime, it's at minus 28 brightness, minus 28 magnitude. So the lesser the number, it means the more brighter it is. Okay, the bigger the number means it is more fainter. Okay, in astronomy, and when it comes to the magnitude of objects in the sky, the sun is minus 28. If you see that particular fireball is as bright as the sun, it is very rare, by the way, to have such kind of an event. If you see such kind of an event, definitely it is going to be a huge asteroid hitting the earth. Okay, so yeah, obviously if you see some fireball which is as bright as sun, definitely it is going to create a huge explosion, and we are going to die, by the way. Okay, that is not going to happen mostly, but yeah. So if you see a fireball which is as bright as full moon, you have to click, you have to actually you can actually move this bar. You can see, right, the blue column, and you can actually indicate, okay, this is this much brightness. If you see it is half the moon brightness, okay, half moon brightness, you can also give that. And also if it is a brightness as Venus, Venus is the brightest thing that can be seen after the moon and sun in the sky. Okay, so Venus brightness, okay, it is actually in the brightness scale, it is around -5. So if it is as bright as Venus planet, okay, you can give that. If it is as bright as half moon, you can also give that it is -9. Okay, you have to indicate that. And after that, you have to mention the color, which is very, very important. Okay, so if you see, the thing is there are multiple colors here. Okay, it is not, sometimes what happens, as I show you, right, the fireball actually may not be in a single color, as it might be passing through different layers of atmosphere. If the event is longer, okay, what happens, it will pass through different layers, right? And different layers of atmosphere have different gases, right? And that will actually lead to different colors sometimes. Okay, and sometimes what happens, this material which is there in the fireball may burn at different times. Okay, the outer layer could be of different material, the inner layer could be of different material, so that also leads to different colors. Okay, so what you have to do, you have to recollect those colors. So if I show you some of the footage of fireballs, they actually look like this. So for example, here you can see there is a fireball event which was captured. You can see what kind of color it is. It is kind of a yellowish orangish color, and if it is too bright, actually you will be color blinded. If it is too bright, you cannot see the colors properly. Okay, so here you can see this event was actually orangish in color, this fireball, okay, which actually happened in Russia a few years ago. So you can see it was very, very bright because the size was big. That's why the color actually turned into white. Okay, but after the event is gone, you can see the trail which is left, which is glowing in orange color, right? And here you can see which is in green color. So that way you can recollect the color and give the color information. If it is of multiple color, you can give the multiple color. So let's whatever fireballs I have seen, mostly have seen them in light green color and blue color. Okay, yeah, most of the meteors, and one of them actually I have seen in a pink color. Okay, pink and orangish color, right, as per my experience. So you can give, but mostly it will be 2 or 3 colors, not more than that. Okay, it is not going to be many colors at the same time. Okay, so then if you see that it is a light green along with a light pink, okay, then you can choose these 2 colors and continue. Okay, now as this event is happening in the atmosphere and traveling with very, very high speed, and it can actually produce a sound like lightning. So lightning, when the lightning strikes, right, it actually expands the air around it, and that actually generates a lot of sound. That's what we hear, the rumbling sound of a lightning, right? Similarly, when a fireball event is happening in the atmosphere, it actually creates a sonic boom sometimes. If it is traveling with, you know what is sonic boom, right? Some jet planes create sonic boom. Okay, the shock waves, if they are crossing the sound barrier, the speed of sound. Okay, so if a fireball is actually traveling with more than speed of sound, okay, then definitely it produces sound. And when it is happening in the lower atmosphere, especially when it is happening in the upper atmosphere, you don't hear much. Okay, if it is happening in lower atmosphere, there is a chance that you will also hear the sound. Only once I have actually heard the sound of fireball. Okay, yeah. So if you heard it, okay, it's mostly you will not be here. Why? Because if you're observing from city, not only just light pollution, you also have a lot of sound pollution, right? The vehicle sound and a lot of sounds of human beings, and all those things are actually going to dominate the sound of these fireballs. Okay, if you are gone, if you're observing from remote location, very calm location, definitely there is a chance that you will hear the sound. Okay, so whatever sound I have heard of fireball, actually it was a very remote event, okay, a remote place, and there I was able to hear that shock wave. Okay, like a very minute, very like it's like a something like this. Okay, very mild. So yes, so you'll hear that kind of a sound. Okay, if you hear the sound, you can actually click yes. Okay, so you have to describe the details of your whatever you heard. Okay, if you didn't hear, you can have to click no. If you don't know, let's say you are doubtful, you can actually click I don't know. Okay, so if you hear any delayed sound, okay, what happens sometimes, the fireball event will be gone, the sound will come later. Why? Because light travels faster than the sound, right? Okay, light travels with almost 3 lakhs kilometers per second. That is the reason you see the lightning strike first. After that, you hear the sound, right? Similarly, when the fireball is actually able to produce a sonic boom, you'll hear the sound later, and you'll see the fireball first. If there is any delay, in the sound associated with the object, you can also mention that. Okay, and also give the description of that. If you didn't hear, you have to click no and continue. Okay, so now what is persistent train? Persistent train means that the streak which is left. What happens when the fireball event happens? Actually, it actually expands. It is firing up. It is creating a lot of temperature, right? That actually leaves a streak behind it. Okay, so the smoke, it's kind of a smoke which is leaving behind. So if you see that kind of a smoke trail which is glowing after it disappeared, right now I have shown one video to you, right? In that, one fireball actually was able to leave the smoke trail. You can see this particular fireball event which happened in Russia, which actually left a very long streak which is still glowing after the fireball is gone, right? And yeah, so these kind of events are very rare, by the way. If you see such kind of a thing, you can actually report about that. Okay, so you can say no if you didn't see that. Terminal flash. What is terminal flash? So what happens? The fireball event will happen. Okay, it will burn for a certain time, and at the end, actually it glows very bright. At the end, it actually glows very bright. Okay, so for example, again, this is a perfect example. Here you can see the fireball on the left. At the end, it actually glows with a very bright flash. Okay, that is called terminal flash. So you can see here also, you can see the terminal flash, and after that it diminishes. Okay, so here also you can see, but not that, here you don't see the terminal flash. This event is not having any terminal flash. Okay, yeah. So that way you can, based on the information that you got, you can actually mention here terminal flash. If no terminal flash, you can say no. And yeah, again, one more thing is that when you see terminal flash, there is a pretty good chance that you will have a fragmentation. That means if the meteoroid is actually of big size, what happens? It will actually break into pieces. Okay, so again, the same example, here you can see it is actually breaking into pieces, right? The right one, the green fireball, which is actually breaking into pieces. That is called fragmentation. So if it is fragmenting, you can click yes. Okay, then describe the details of the fragmentation. Okay, you can see, is it splitting into multiple things, or is it back-to-back fragmentations? All those things you can. And if there is a fragmentation, is it creating another meteor in other direction? All those you have to mention. Okay, if you don't know, you can click I don't know and continue. So here is the final step of this reporting. Okay, what you have to do, you have to give the name. Okay, you have to give the email ID, and you have to rate your observing experience. Okay, so here, if you don't have any astronomy experience, you have to click 1. I have no astronomy observing experience. If you are little bit interested and you have seen some, you have done some observations before, you have to click 2. I have some astronomy observing experience. And if you're like casual observer of meteor showers, okay, especially if you're interested in those events, you have to click 3. If you're having some experience, like I rate myself regular, this 4 actually. I observe meteors regularly and consider myself an amateur astronomer. You can give that. Or if you're an expert, okay, if you have done some research already, can give that I'm an expert level observer and astronomer. Mostly the scholars, the PhD holders will come into this category. Okay, yeah. So you have to give this experience according to that. And any remarks, if you want to comment anything additional apart from that, okay, you can also comment all this thing in this. Okay, so you have to click here, submitting this data. Before submitting this, and then you have to submit. Okay, so it will submit. Okay, but here actually I have reported falsely, right? So once you report, okay, so even whatever you are giving the information, they will accept it. Okay, but after submitting, it will go under some review. Okay, so it will go under pending reports, right? So right now you got the identification number like this, and let me show some of my reports from previous years. Okay, so let me show that. So here, this event, so when your report is actually confirmed, it will become an event. When your report is actually confirmed by this organization, it actually becomes an event. So this is an event from 2017, which I reported. Okay, in 2017, you can see all the details I have given. Okay, remarks I have given. Okay, then I have given the terminal flash. There was a terminal flash actually. Whatever I observed, in 2017, like I said, okay, this was the best fireball I have ever seen. Okay, so you have to give all this thing information. Okay, it was a purple, pink, as I said. Remarks you have to give. I have given this. It started with white color, originating from Taurus constellation. I have given the constellation name also, and then suddenly started glowing in pink, and then seemed like it kind of fragmented into pieces with whitish dots, and then final bright with white burst. Okay, that is a terminal flash. Final burst was as bright as a full moon, and it might have probably ended in Andromeda constellation. Okay, there was Andromeda constellation there in western sky. So I have given this extra information so that it will help the scientists to better understand this. Okay, so that actually, if you are giving a right report with all the information, then actually it becomes an event. Okay, so that way, so far I got 5 events. Okay, on my name for this fireball reports. Okay, so that way you're actually helping the scientists to to understand the material which are actually present in this, and also what is the occurrence of this, how many they are occurring. Okay, so because these events are very, very important to trace back their origin, from which comet they are coming from, which asteroid they are coming from, then they can understand the composition of it, and even they can actually understand based on the size of an asteroid. If you know the composition of an asteroid, they can actually, looking at the asteroid size, we know how much heavy it will be without measuring its weight on a weighing scale, right? So how beautiful is this? We are having the simple tools that, like our eyes, our brain, okay, all these softwares, right? Using them, we can actually do real science. Okay, we can actually weigh an asteroid. We can actually know how big, what is the material which is present in these comets and asteroids. Okay, which is very, very good. Okay, so yeah, and these meteors and fireballs are falling every day. It's not like rare events. Every day these events are happening. Do you know what? These events are actually adding mass to the Earth. Okay, yes, that's very interesting thing. So from satellite observations, it is this is a meteor. This is a fireball actually, which is captured from International Space Station. It is estimated that about 100 to 300 metric tons of material strikes Earth every day in the form of meteors and meteorites. Okay, yes, that's very interesting, right? Okay, Earth is also losing some mass, by the way. You can research on that. So if meteors are adding mass, then how the mass is losing. So you can also research about that. So here again, I'm giving the timer. Okay, so again, as you understood about these different objects, right? Now, so again, now I'm posting this question to you. Recollect. Yes, I'm giving 20 more seconds. So most of you now, you should be able to answer correctly. Yes, I hope you are ready with your answers in your mind. Now, compare your, whatever you thought, and look at here. Okay, dwarf planets, we have comets. Okay, so comets are actually visible for longer period. Okay, they are not like meteors. Okay, They are huge objects, obviously. When they come near to the sun, they glow, they generate a tail, and they will be visible for a few days to few weeks. Okay, so they are not shooting stars. Okay, they are not meteors. Okay, the pieces of these comets actually turn into meteors. Okay, so yeah, if you know right now, you know about the difference between all these things, right? Which are actually coming under minor bodies of solar system or space rocks. Okay, yeah. Okay, that's great then. So I hope you're ready to look at these fireballs and meteors and report to these organizations, right? IMO as well as AMS. Okay, you can Google search about them, and actually, I'm looking forward. So once you have done the observation and once you report that, okay, you just send me the screenshots of them. Okay, like I showed. Okay, you can actually take a screenshot of that particular report and please upload to the community. So let me again take you to the community. So let me look at the questions. If you have any questions, let me look in the community. Yeah, so I see that some of you are answering already in the community. Okay, meteorite, superb. Okay, asteroid. Um, yeah, why are meteorites smaller than asteroids? Because they are pieces of. Okay, meteorites are pieces of the asteroids, right? So when asteroid breaks into multiple parts, okay, and this the whatever part is broken is actually called meteoroid. Okay, and meteoroid, freely roams in the space in the solar system. When this meteoroid actually strikes the atmosphere of the Earth, it becomes meteor. And when this meteor is big enough and strong enough to survive, and when it falls on the Earth, it is called as meteorite. I hope that is clear. Okay, super, good question. Yeah. So, sir, why are these too small and why are asteroids bigger? Because asteroids are actually leftover bodies of solar system, right? Leftover pieces of solar system. They are actually bigger. Okay, some asteroids are even hundreds of kilometers in size. Okay, if it is too much big, what happens? It turns into spherical shape, and that is called dwarf planet. If the asteroid is very big, for example, we have asteroids which are actually spherical in shape because they have huge mass and gravity. They are called Vesta. Okay, Eris, make. These are actually spherical in shape. They are also asteroids, very big, because they are leftover pieces of the formation of solar system. They're very big. Okay, so asteroids, yes. MCP report. Okay, that's fine. Asteroid, you're answering in the as the expert. Okay, superb. Okay, very good questions, by the way. Keep asking these questions, and we would be happy to answer all of your questions in the community as the expert session. Okay, and I'm really looking forward for your observations. Okay, whenever you go on the vacation right now, Christmas holidays are coming, New Year holidays if you have holidays, and also Sankranti. Okay, Pongal holidays are coming. So definitely, if you're going out somewhere, or even if you're not going, so right now it is the best time to observe these fireballs and meteors. Okay, tonight actually, don't wait for the vacation. By the way, today is Sunday, right? You can actually go. You can spend some time on top of your terrace. Okay, just observe. Take your parents there. Okay, be safe. Okay, so just observe the sky for some time. You have to at least spend 1-2 hours to see something. Otherwise, there is less chance. If you are lucky enough, if you go, you'll see it. I was very lucky that once I go on to the terrace, immediately have seen a fireball. Okay, it was very good experience for me. So definitely, I hope that you will see a lot of wonders of space in the form of meteors and fireballs. And these fireballs and meteors might actually, I hope that it will create curiosity. It will spark the curiosity in your mind to know more about them. And maybe in the future, you will be actually working in the labs to study about them and unravel the secrets of this universe. Okay. So all the best for these observations, and I will see you again in the future sessions. Bye bye. Take care.